Hi geometry students. This video is on congruent chords, which is section 10.2 in your textbook, and the vocabulary with or surrounding arcs of a circle, which is section 10.3 in your textbook. So we're going to first start by talking about two theorems. It's one new theorem about congruent chords and its converse. We don't need that apostrophe. It should just be its without an apostrophe. Converse. So the theorem says if two chords of a circle are equidistant from the center, then they are congruent. So I'm just going to kind of relate that sentence to the visual. So the idea is the thing that we're given, the if that we're given is that the two chords are equidistant from the center. So that means that point P is equidistant to point X and point Y. So that would be XP is congruent to YP. Then this term tells us that those two chords, the associated chords with those two distances, are also congruent. So we would know AB is congruent to CD. So the converse is reversing the theorem. So starting with the conclusion and ending with the given in the previous theorem. So it will say if two chords of a circle are congruent, then they are equidistant from the center. So if I were to write that kind of relate this sentence in words to the diagram, I would start with now the chords being congruent. So I would say if CD is congruent to AB, then I know that FO is congruent to EO, because those would be the distances that each chord is from the center. Because remember that when we talk about distance of a segment to a point, we're talking about the perpendicular distance. So we're not going to prove these two theorems today, but if we were to prove them, we would use congruent triangles, similar to the one we did in class last time. So let's just look at an example of how we can use these theorems to solve problems. So in this situation, we're given that chord AB is congruent to chord CD, and then we're given expressions in terms of X for OP and OQ, and it's asking us to find OP. So the key piece of understanding here is that if we know the two chords are congruent, then in OP and OQ are the distances that each of those chords are from the center. That must mean that OP is also congruent to OQ. So that means I can set equal 12x minus 5 and 4x plus 19. And from here, this is just an equation I can solve. So I could subtract 4x from both sides. So now I have 8x minus 5 is equal to 19. I could add 5. And then I get 8x equals 24. Divide by 8, and I get x equals 3. Now it's asking me to find OP. And I know OP is 12x minus 5. So at this point, I'm plugging 3 in for that x. And I get 36 minus 5, which is 31. Okay, so OP must equal 31. Now, what I'd like you guys to do is pause the video and try out this next U-try problem, which should be similar to the one we just did. And then press play when you're done, and I'm going to keep going with the notes. Okay, so now that you've tried the U-try problem, we're going to talk about what an arc is for the remaining part of the notes. And this is going to be some more kind of vocabulary here. So an arc, if you kind of look down here, these are all examples of different arcs. And they relate to a circle, but they are not the same as a circle. So an arc consists of 2 points on a circle and all the points on the circle needed to connect those 2 points by a single path. So we'll say to connect those points by a single path. So if you notice, first of all, if you look at each of these, you can kind of imagine each of these diagrams, you can kind of imagine that they are a part of some circle that we can't quite see, right? We can kind of draw like some dotted lines to complete the circle, something like that. So we can see that they all lie on circles, and they all have 2 points labeled, and then you see this kind of connection along the like path of a circle between those 2 points. So between A and B, there's an arc. Between C and D, we arced it the long way around this time, and then here E and F, they actually kind of look like if we connected them, it would form a diameter, and this is also an arc. Okay, so that's all that we're doing on the front. Now I'm going to flip to the back. So a lot of times we describe, we talk about arcs in terms of specific central angles. So I want to define what a central angle of a circle is. So we say a central angle is an angle whose vertex is at the center of the circle. So remember that the vertex of the angle is like where the two rays come together, right? So notice in this diagram that the center of this, the vertex of this angle is also the center of the arc. So we would call this, if I were to name it, I would name this angle AOB. And that's not necessarily new, but that's what a central angle looks like. We always assume it connects to the center of the circle from 2 points that lie on the circle. So next thing is looking at what are the different types of arcs. And we have 3 different types. We have something called a minor arc, a major arc, and a semicircle. Semicircle probably already sounds familiar and you know what it is, but the other 2 might seem unfamiliar. So for a minor arc, we say it's an arc whose points are on or between the sides of a central angle. And that might not make so much sense, but let's draw a diagram to kind of understand this a little bit better. So suppose I have 2 points on my circle. I'm going to call them A and B. And the minor arc here would be the ones that connect A and B between the sides of a central angle. So it might be helpful to draw in the center of my circle. Let's call it O. And then we can see, okay, there's the central angle. So the arc AB would be this part I'm shading in green. And the way we would name it is we would say AB, and we draw like a little curved line above it. So we would read this as arc AB, okay? And the key is that it's between the 2 sides of the central angle, so it wouldn't be going the long way around. It would be going the short way around because my central angle is there. It's not the big angle, it's the small angle. So one way I think about the minor arc is it's like the short way around. And that's just kind of like a common sense kind of way of thinking about it. And now let's see what a major arc is. I'm going to call it the long way around. So I'm going to draw so we say a major arc is an arc whose points are on or outside the sides of a central angle. So I'm going to draw a really kind of similar diagram. So I'm going to try to put A and B in about the same place. And there's my central angle. Okay, so if I want points, so I want to include points A and B, but instead of going between the sides of the central angle, I want to go on the outside. So I'm actually going the other way around. So I'm going to call this the long way around. Okay, and now since the minor arc was arc AB, and I can't call this arc the same arc AB, we have to have another way of calling it. So what we do is we kind of insert another point on the circle. And so suppose we have our center O. I'm going to put points A and B, and I'm drawing them specifically so that because I know when I connect them, they're going to form a diameter. Then the semicircle would be, I could go either way. It doesn't actually matter. I could do that way or that way, but both are semicircles, right? And this would also be arc. I would just call this arc AB. It doesn't matter which way I go because they're essentially the same arc. Okay, so the last thing we're going to kind of review on these note sheet is how do we describe the measure of an arc? And it's pretty simple. The measure of a minor arc or a semicircle is the same as the measure of the central angle that intercepts the arc. So what does that mean? It means whatever the measure of this angle is, like in this picture, that would also be what we would say the measure of this arc is. Same with the semicircle. With the major arc, it's a little bit different. So we would say the measure of a major arc, well, it's everything outside of that central angle. So what does that mean? That means it's 360 minus that other angle, okay? So we would say the measure of a major arc is 360 degrees minus the measure of the minor arc with the same endpoints. So let's look at some examples of how we can kind of use those two pieces of information. So for these three, we're going to look at this diagram right here and see if we can figure out. So this is a new notation here with this M in front. So we can say M arc BC, meaning the measure of arc BC. So if I look at my diagram, I see here's B, here's C, here's arc BC. So I can already see that there's a right angle there, so that means that the measure of the arc is 90 degrees. And the way we denote that in a diagram is actually by writing a 90 degrees like on the outside of the curve where the arc is, as opposed to like, I could have also written 90 here, which would mean 90 is the measure of the central angle, but when it's out here, it means it's also the measure of the arc. And yes, those things are the same. Okay, so then it says the measure, for the next one, it says the measure of arc AC. So I'm going to use green now, so I'm going to say here's A and here's C. And it's asking for, because there's only two letters, it's asking you to go the short way around. So the short way around would be this way. And I can tell that that's going to be, well, this arc AB here is labeled 70, and then from B to C is labeled 90. So I know that all the way around should be 70 plus 90, which is 160. And then to do APC, now this is the major arc, because it's saying go from A to C by way of point P. That's the long way around. And in order to do that, I have to say, well, that distance should be, that measure should be 360 minus whatever the green one was, right? So 360 minus 160, so it should be 200. Okay, and then we have one example here with the second diagram, which is now here we have AB as a diameter. So what is the measure of arc AB, which would be that? Well, it's exactly the measure of the central angle, which is a straight line. So it would be 180 degrees. Okay, so the last thing we're going to ask you all to do for these video notes is to say, taking a look at this diagram, can you find the measure of each of these arcs? And we will be going over the solutions in class next time.